L.1.7. We still have a learning goal of working with absolute value equations, but notice I've added something to it. I can write. In other words, you're going to have to set up your own absolute value equations today. So I can write, solve, and graph absolute value equations. So included into our goal now is, how can I set up my own absolute value equation? Okay? Well, there's a nice model to use. If you use this model to help you set up absolute value equations, you should find yourself being successful. And notice what it is. It says, in absolute value bars, take the variable and subtract from it the middle value, in other words, what you want it to be, and then set that equal to the distance that expression can represent. Okay? So that's just a model that we're going to use. So let's start practicing and just using it. Number one, write and solve an absolute value equation that represents two numbers x that are 4 units from 1 on the number line. Now let's just explore and see if without writing an absolute value equation we can figure that out. Do you think you know two numbers x could be that are 4 units from 1 on the number line? Anybody think they know what those would be? Cody?
5 and negative 5.
5 and negative 5? How'd you get them, Cody? What'd you do to get 5 and negative 5?
Because it says represent two numbers x that are 4 units from 1 or 1 and negative 1, because you can't have a negative distance.
Well, it just says that are 4 units from 1 on the number line. So let's just check it out and see if you're right, okay? So here's 1, and we need numbers that are, it says 2 numbers that are 4 units from 1. So if we go 1, 2, 3, 4 to the right, we end up at 5. So that one is correct, isn't it? But if we go 4 units in the other direction from 1, where do we end up? Do we end up at negative 5? 1, 2, 3, 4, we end up at negative 3, don't we? So the two numbers that are 4 units from 1 are actually 5 and negative 3. Those are what we would consider the solutions. Okay, so what's the distance in this problem? What did we use as distance? 4. And what is the middle? The number that is equal distance from both of those numbers. What's the middle in this situation? 1. Yeah. So the middle is 1. The middle is 1. That's where we want to start. And from there we want to go 4 units. So we already know the answer. We already know the solutions, but we're going to see if we can get an equation that would actually get us to those. An absolute value equation that would get us to them. So we're going to use our model. It says up here, in absolute value bars, do x take away the middle. So x take away what?
1.
1. Remember how I said make those absolute value bars tall enough, as I'm messing up mine, make your absolute value bars tall enough that they don't look like a 1. You're confused, you think we got x minus 11 here, equals the distance, which is 4. Okay. So let's solve that now. Do we know how to solve absolute value equations? So how do we solve this? What would we do? What would we do to solve this? If we know how, what do we do? We've been doing it for days now. Julia? Not yet. I can't add 1 to both sides yet because I haven't gotten rid of the absolute value bars. Rewrite it. Getting rid of the absolute value bars. Oh, this is set equal to a positive number. How many solutions will there be? 2. So I can set x minus 1. No absolute value bars anymore. I can set it equal to what?
4. No, 4.
4. But I also can set it equal to the other number that has a distance of 4, and that is negative 4. Okay? So we had to set up our own equation, but now we're just using the same process we have all along. Set up our case or cases that'll help us get the solutions. Okay, now, Julia, what should we do to both sides? Add 1. Okay, let's add 1 to both sides of the equation to get that x alone. We're gonna have x by itself now on the left, and 4 plus 1 is 5. One of the numbers we said is 4 units from 1. And then let's go solve our other one. Same thing, right? Add 1 to both sides. And x is now by itself. Negative 4 plus 1, negative 3. Was that the other number we said is 4 units from 1? So we could make sense of the problem to begin with. We could get the answers without setting up an absolute value equation, but we should also be able to write an absolute value equation to represent the situation and get us to those solutions. Okay, so these are our solutions. Well, today we're going to actually graph them when we have to write our own. And sometimes students find that it's actually easier to graph first. You figure out the answer to the problem and graph it, and then take it from there to help you get the equation that'll take you to that graph. Okay, so sometimes you end up finding, so we need a negative 3, so let's start with negative 3. And we'll put what equidistant tick marks because we're going to do integer values. So negative 2, negative 1, the next one would be 0, right? And then, so I'm just like not labeling them all. You can, if you want, negative 2, negative 1. And then we keep going, 1, 2, 3, 4. I got to erase because I'm running out of room and I want to make a good number line. I don't want to just cram another tick mark in there and say distance does not matter, because it does. We should have about equidistance between these tick marks because that shows good number line sense. Have we done any graphing yet, do you think? All we did was set up a picture of the number line. What part of the number line do we want? Can we draw a whole number line? Can we draw a whole number line and label every possible real number on it? What do you think? We can. Okay. Hope you don't have any plans this weekend or next year. Hope you live to be an infinitive age, because it's going to take the rest of time. And if the world ends, which it will, let's put it like this: when the world ends, you'll still be drawing the number line. We can't. We have to take a snapshot of it. We have to take a snapshot of it. Here's a snapshot of our number line. This is the part of the number line we want to show. And now we're going to put our 5 on it. Now we're graphing. We're putting a point at 5. We're putting a point at negative 3. And we're seeing that those are the solutions that make our equation true. Those are the two numbers x can be that are 4 units from 1. And it should verify. Let's do it. Let's just verify that they are 1, 2, 3, 4. We end up at 1. 1, 2, 3, 4. We end up at 1. So we have good solutions. That's going to be our check. Because you know what? If you set up the wrong equation and you solve it and you get your solutions, are your solutions going to check in your equation? Most likely they will, because you got to set up the equation, didn't you? But if you set up the wrong equation, is it possible you have the wrong answer?
Yes.
Yeah. So those check problems today are better done on a graph like this. It shows that, you know what, these numbers really are 4 units from 1 on the number line. Okay? So anybody got questions about that? Okay, let's go to the back then and see what I have us doing back there. Oh, it looks like we gotta go to page 57. We're gonna do number 13. Page 57, number 13 we're gonna do together. Okay, communication. Barry's walkie-talkie has a range of 2 miles. Barry is traveling on a straight highway and is at mile marker 207. You guys know what mile markers are on the highway? You seen them ever? Yeah, we know what they are? Are they green?
They're small.
Small and
Things
little.
about this far off the ground.
Yeah, and they have numbers marked on them. And they're, so write and solve an absolute value equation to find the minimum and maximum mile marker from 207 that Barry's walkie-talkie will reach? Now this is so basic that you're probably already thinking, I already know the answer to that. If Barry's at mile marker 207, his walkie-talkie has a range of 2 miles. Do we know to what ends, to what mile markers his walkie-talkie would work to? What are they? 209, add 2 to 207, it's going to be 209. It'll go out that far. But it will also go to what? When they go back to? To what?
205.
205. So it's like the minimum is 205. So if somebody is behind him and he's using a walkie-talkie and they're at least a 205 mile marker, 205, will they get to talk to him?
Yeah.
Yeah. And if they're beyond him and they're to mile marker, they haven't, gone past mile marker 209, are they going to be able to talk to him? Yeah. So the minimum is 205 and the maximum is 209. And what's that 207? The middle. And what's the distance? 2. It goes 2 miles, doesn't it? Okay, so the middle is 207. The distance is 2. We're ready to set up our equation. Go ahead, write an equation for that. Write an absolute value equation that will help solve that. In the end, we really should get those 2 answers we already know, 205 and 209. Don't solve it yet, just in case you have it on your own. Waste your eraser. Share with me an equation. Devontae, share yours with me.
X subtract 207, wait, is that right? Yeah, equals 2.
You all agree? Devontae, did I leave anything out?
The absolute value numbers.
Oh, where do those go?
Behind the X in front of the 207.
Behind X and in front of the 207? Do you mean it the other way around? Do you mean in front of the X
Oh, yeah.
and behind the 207? That's what I thought you meant. Okay. Do you all agree with this equation?
Yes.
Okay. Let's solve it and see that if it works. Okay.
Wait.
do you
You
want?
can do it in negative 2. Don't we have to do both of them?
Oh, wait a minute. We're just setting up the absolute value equation. If we set it equal to negative 2, is there a solution for an absolute value equation when the expression is by itself and set equal to a negative? Can we solve that? No, we can't solve that, so we don't want one like that. This is our equation, okay? So here's the equation that we want, but then we're going to solve it, and what is not in our solving step, even though some of us have it in, and that just can't get you to quit? What don't we have in our solving step? What, Aurora?
Absolute value bars.
Yeah, we don't have absolute value bars in our solving step, okay? So how many solutions are there going to be that set equal to a positive number? 2. So we have x minus 207 set equal to any number or numbers that have a distance of 2. They are 2 and negative 2. So I have x subtract 207 set equal to both of those numbers. And now I solve both of those equations and see what we get. Okay? So go ahead and solve both. I'm feeling pretty good. I got 205 and 209. How about you?
Yeah.
We already figured those out, hadn't we? Okay, which one's the maximum?
209.
209, so we're going to say maximum for this one. And which one's our minimum? 205. And of course, what's in the middle, right smack down in the middle between those two? 207, where Barry's at, right? Okay. So even though we can get the answer very simply without an absolute value equation, I get that, but we need to know how to set them up and see how they can help us, especially when it isn't as simple as that. So any questions about it before we try it? The other thing we have to do today. Okay, then let's move on to that. Write an absolute value equation. What did I do again? Okay. Write an absolute value equation whose solutions are graphed on the number line. In other words, they're saying these are the solutions. You have to come up with the equation that they came from. So what are the solutions in number 2 here? -2 and +2. So let's write that. Solutions. We're going to say x equals -2 and 2. Those are the solutions. The number line tells us that. We have points graphed at those locations. Okay, so we have to come up with the equation that those came from. Think we can do that? How are we going to do that? We're going to use those in our equation. So, did I introduce a model to you that should help us set up the absolute value equation anytime we want? How does it go again?
X minus middle equals distance.
Yeah, x minus middle equals distance. Well, that's why I wrote here middle is and distance is. What's the middle? 0. The mirror's the middle right here. The middle is 0. What's the distance from 0 to those ends? 2. So, can we write our equation? Sure can. What is it?
X minus 0 equals 2.
Okay, x minus 0 equals 2. Okay. If we solve that, what should it do?
Equal 2.
Equal 2 and? -2. Okay, so if we solve this, but you know what? I also want you to do this. We always know that especially when we're taking those multiple choice tests, and they're grading us on them, they're saying, okay, you're smarter than the average 5th grader or whatever. There's always, these A, B, C, D answers, and you work a problem and you get an answer, and you're feeling so confident that you knew what you were doing, but you get to the answer bank and your answer isn't there. What does that mean? Does that mean you did it wrong right away?
No.
Should that be your first thought? I must have done it wrong? No, what should your first thought be? Can I simplify it? Can I rename it? Can I clean it up? That's what you think this could be cleaned up? Do you think there's another name for this one?
Yes.
And it still has the absolute value bars in it? What is it?
Absolute value of x is equal to 2.
The absolute value of x equals 2. Why can we ditch that subtracting 0? Why is that not a big deal?
Because 0 is 0. Technically nothing's there.
Yeah, we're not taking anything away, right? If you take something away from x and it's 0, it's still x. Okay, so we can clean that up. It could still be shown this way, but we also got to know, what, if it isn't, maybe I need to just rename it, clean it up, and maybe that's the name that will be in there. Okay. Now, let's solve this one because this is going to be a lot easier, right? What do we have to do? To ditch the absolute value bars, we set it equal to any numbers that have a
Same.
distance of 2. What are they?
2
2 and x equals 2, x equals -2. Have we already solved it? Is there any other solving steps? No, it took us right to it, didn't it? And those are the solutions that the number line shows. Feeling good about our equation. Okay. Why don't you try number 3, see what you come up with for an equation. Try number 3, see what you can come up with for an absolute value equation that when solved would give you the solutions on that number line. Okay, who's brave enough to share their equation with us? Aurora.
X minus 3 equals 4.
I like it. How about the rest of you? Is the middle 3?
Yeah.
Yeah. Is the distance from 3 out to those 2 points 4? Okay, so this looks like a good equation, doesn't it? Okay, so here's our equation that they wanted us to write. And when we solve it, what should happen?
Equals 7.
Equals 7 and equals -1. Okay, go ahead and solve that. Make sure it does. Make sure that our equation gets us to -1 and 7. Doesn't matter which one comes first, but does it get to that? Okay, it worked for me. Did it work for you?
Yes.
Did you get those 2 solutions? Yeah? Okay. So when we have to do this in your homework, don't just write the equation. Yes, that's what they're going to want from you. But then verify it. Check it out. Make sure that your equation is really going to get you to the numbers that are on that number line. Okay, we have one more we're going to do. Let's do this one together. What's the middle?
-2.
-2, okay? So we're going to have x subtract
-2.
-2. That subtraction sign does not take the place of the negative sign. It's always going to be subtraction. Take away the middle, equal to the distance. What's our distance this time?
3.
3, because here's our middle, you said, and it's 1, 2, 3 units. No matter which direction you go, the distance is 3. Okay, is that how you're going to see that in an answer bank? What are they going to do? How are they going to clean it up?
X plus 2.
X plus 2. They're going to change it to add the opposite, aren't they? So it'll be x plus 2. That is how they're going to show it in an answer bank. They're going to clean it up like that, I guarantee you. So you're working an odd numbered problem in the homework, and you're in the book, and you go to the back of the book, and you had x minus a -2 in absolute value bars equals 3, and it's not that. It says this instead, x plus 2 in absolute value bars equals 3. You're not going to just like erase your x minus -2 equals 3 and say, oh, I was wrong. This is going to be it. You're going to be like, oh yeah, I can clean this up and it will be exactly that. Okay? Well, we are going to stop there. I'm not going to solve that. I'm going to leave that up for you guys to do on your notes yourself. Okay, sometime you can do that. Let's get your homework out to you.